Hi, everyone. Thanks for watching. Today, I want to talk about something that I just got a question about, and that is for old wood frame multifamily residential buildings that have no insulation throughout. So it's just wood. Um, the top level guys, like let's say it's a four-story multifamily wood frame building built 40 years ago, about in the 1960s or the 70s. Actually, in the 80s, 40 years ago, it's in the 80s. Usually the top level guys don't hear neighbors from above, right? Because they're on the top level. But everyone else who live below are kind of used to the footfall and neighbor noise from one another just because of the nature of the building. So they're all okay. But the top level person is not comfortable during the summer when the roof deck above him or her is being used quite frequently. And understandably, all of a sudden, the roof deck that are usually untouched through the other times of year. In the summer, it's super popular. So there's footfall noise coming into their apartment or their space all the time. So I was approached and asked about some solutions. So just brainstorming here. I mean, bespoke consulting where I give details and exact instructions on how to build things and the different performance levels of different options. That's a different story, but I just want to do a general brainstorming of what different approaches are possible. And if you don't have access to acoustic consultant or people who know what they're doing, this is going to help you. Whether you're a strata or property manager or you're the building owner or someone who is aware that this is a problem and want to fix it, roof deck noise transmitted into spaces below and causing issues, then keep watching. So the main issue with older buildings that don't have insulation is that there's not much separation between the roof deck, especially people's footfall onto that roof plane. That would usually it's a in the Pacific Northwest in Vancouver, it's going to be like a plywood with a torched on waterproofing membrane. I don't know, maybe there's rigid insulation that doesn't do anything for acoustics whatsoever. And then there's the wood framing like joists or web trusses, right? Um, I'll try to find an image and insert it into the video, but web trusses, that's a hollow cavity, and then there's a plywood or gypsum board underneath to the space below. And that is like almost no protection from footfall noise. So what we want to do is to introduce a soft layer between where people's foot or shoes hit the top roofing membrane um, and the roof and the actual structure. So we want to separate the foot from directly hitting onto the roof. So what can we do about that? So there are products that are recycled rubber or other resilient material. We usually use them for gym isolation, like, gym flooring. It's kind of rubbery, it's kind of bouncy. So we would use that kind of material. Make sure that it's okay for outdoor use. It's not going to mess with the waterproofing or the UV exposure of UV, I don't know, durability of that roofing material. We would introduce some sort of a rubber grid or rubber padding. The thicker, the better. Okay, that will help um, reduce the amount of footfall. Even if you do introduce that, and sometimes you can put like artificial turf over the top of that. Like the thicker, the better, like artificial grass, and just stick it over top of that thick, resilient rubber layer. And then that should help take out the sharper, bangier parts of the footfall. Um, I'm not entirely sure that it will take out the thuds and the lower frequency thumps especially when there's a heavier person or um, heavier items being moved around. That will take mass. You have to introduce more weight into the system. For example, you may have to put stone pavers on top of the resilient rubber pedestals, or build out something else. And not every wood frame structure is able to take that weight. A more invasive strategy is to install resilient gypsum ceiling on inside the unit below. So for the resident below, you have to go into their place and then install full resiliently hung or gypsum panels supported by resilient channels installed correctly with no flanking path. No flanking path means no sound leaks, no rigid connection around the perimeter of your ceiling installation. So those are just some simple preliminary brainstorming as to what the standard solutions would be. And if you are a consulting client, I would typically give more detailed specs because every building is different and every application is different. So the design for the actual assembly, how thick each material needs to be, how soft they need to be, what kind of materials, which brands carry them, who are the suppliers, and what are the sandwich assemblies. Those are all information that I would give you when I'm consulting for your project. So I hope that helps. I hope that gives you some ideas. In general, you want to break the rigid connection between where the foot, where people are walking, where the foot lands from the rest of the roof structure. Okay, that is the first thing you want to do. So you can achieve that through wood chips, like thick wood chips, or thick rubber, thick cork, um, artificial turf over some sort of thick gym mat finish, those kinds of solutions. And while that depending on your existing ceiling roof structure, that might not take out the low frequency thuds and the thumps, in which case you will need to introduce more robust installations over your roofing. Consider installation inside the roof cavity and or install additional gypsum ceilings in the unit below. So that's it for today. I hope that was helpful. And if you are a smart contractor, if you know what you're doing, you probably get a lot out of this talk. So I'll see you again next time. Thanks for watching.